factor is what? The ratio of RMS value of the alternating quantity to that of average value of the alternating quantity. Alternating quantity is what? It might be a voltage, it might be a current. But derivation what I did for current. So that the ratio of RMS value to the average value. What is that RMS value for the current? 0.707 into IM. Average value is what? 0.637 IM. IM both get cancelled. 0.707 divided by 0.637 is what? 1.11. Form factor is a constant which is equal to 1.11. For which quantity? Sinusoidal quantity. If any quantity which changes its magnitude as well as direction in the form of sinusoidal waveform, okay, then whose form factor value is 1.11. Got my point? Okay, this is what the definition of form factor, the ratio of RMS value to that of average value. This is most important for the examination point of view. Many times this question is repeated. Next, peak factor. Next is what? Peak factor. Already you know the representation of the sinusoidal waveform. Okay, this is what your sinusoidal waveform. Okay, which it is having peak value at 90 degree. Okay, if it is a voltage, then it is Vm. If it is a current, Im. Okay, peak factor is the ratio of maximum value of the alternating quantity to that of RMS value. Okay, alternating quantity I have represented. What is that alternating quantity? It might be a voltage, it might be a current. Kp is equal to maximum value to that of RMS value. That is called as peak factor or the crust factor. Im divided by 0.707 into Im. Im will get cancelled. Okay, what is this? 1 divided by 0.707. It is 1.414 for the what? Sinusoidal waveform. That you have to remember, not for any other waveform. The peak factor itself is the ratio of maximum value to that of RMS value. Okay, this definition is also be repeated in the exam. Okay, you can capable to define that properly. Is this clear? Okay, yeah. Form factor and peak factor. Okay, these two are important for the examination point of view. Okay, then representation of alternating quantity. Okay, but it is to understand the concept. Okay, in generation I have told what I told. The conductor is rotating. Okay, in 360-degree rotation in the circular fashion. Okay, if it is there at 0 degree, voltage is 0 or the current is 0. At some other angle, okay, I have taken at a 5th position. At that instant, some value of the quantity is present, which it is varying sinusoidally. Remember that with respect to the rotation. Then 90 degree, I will get maximum value. For 180 degree, again flux will be 0 linked with respect to the conductor, current will become 0. Then if it is again 270 degree, maximum value, but it is negative direction. Okay, then if it become 360 degree, again current will become 0. Okay, this will be taking place with respect to the complete positive half cycle as well as the negative half cycle. Whatever the direction which is to be taking place in order to produce the current or the voltage. The quantity which it changes its magnitude as well as the direction with respect to the time itself is called as alternating quantity. This is itself is also be called as vector quantity. Got my point? Okay, this is the representation of the what? Alternating quantity. okay, which changes its magnitude with respect to the time, that can be represented by Im for the maximum values. The instant at which the voltage which is to be appeared or the current which is to be flowing, that instant of the voltage is itself is called as instantaneous voltage. If it is the current, instantaneous current. What is the equation for instantaneous current? I is equal to Im into sine omega t. Okay, you have to remember this. If it is voltage, V is equal to Vm into sine of omega t. That is the instantaneous voltage. Okay, corresponding to that of evaluation of each of the quantity to be considered for the evaluation point of view, you need to consider. What are the topic I have considered? Generation of sinusoidal voltage. Okay, frequency definition, maximum value or the amplitude definition, RMS value, okay, average value, then form factor, peak factor. Okay, go through the notes. If you are not understanding the concept, then you can approach. Is this clear?
Yes, sir.
Sure.